Hello! This is a talk that I gave at Lab Week 2018. This is a re-recording because the talk wasn't recorded at the time, and it is for anybody who was hoping to see this but missed it for whatever reason. And so this talk is about designing a more ergonomic IPFS API. Bonk. How can IPFS API be more appealing to programmers? That's the question I'm trying to answer. I believe we can make it easier to program for IPFS. I believe that programming for IPFS can be more enjoyable. I believe that programming for IPFS can be more exciting. And I think that solving these problems can encourage developers to use IPFS. So I'm kind of thinking about what would I like to code. So like if like I was designing the IPFS API, what would it look like? Now, I don't think we should just change things on a whim. There's a whole spec. There is a lot of code that is sitting on and using defined APIs, and just changing them like that. I realize that it's a significant upheaval to be doing that. So I don't want to do it without good reason. That said, I did start out on this thinking up reasons why we should go about doing this, and I came up with more and more and more reasons. And there seems to be an increasingly large set of them that are kind of pro changing things and I'll take you through some of the things that I'm proposing in a minute. And so basically this is about improving developer experience. And to do that, I created a repo, obviously, called ipfsx. The X is for experiment. And it's basically a playground where we can try out new programmatic interface ideas and see if they work or not. And if they don't, then we change them. But like it's for getting some feedback, getting some ideas, implementing them, and seeing how we can make using IPFS easier and better for developers. And so what ipfsx is currently just a mapping layer from the API that I want to expose to the API, the core interface API that IPFS or IPFS API exposes. And one of the biggest things that I've added to ipfsx is making use of async iterators instead of pull streams and Node.js streams. So what are async iterators? Well, okay, firstly, iterable is an interface for producing iterators. There are lots of things that are already iterable in JS already, so like arrays, objects, maps, and sets. And that means you can use them in for x of y loops, where y is your iterable object. And so an iterable object is basically exposes a function that creates an iterator. And once you've got the iterator, you can use that to iterate over all of the items. And we do this because you might want to be able to iterate over your set multiple times. An iterable can create multiple iterators. And depending on your implementation, you might only be able to iterate over it once, but the interface allows you to decide whether or not you want to do that. So an iterator implements the iterator protocol, and that just means it basically has a next method, and that next method returns an object that has a done and a value property. Done is true when the iterator is finished, there's no more items to iterate over, and value is the next value that's coming out of the iterator for you to consume. Okay, that's iterators, but what are async iterators? Well, async iterators instead return a promise when you call next. So instead of an object that has a done and a value, it's a promise that actually resolves to an object with a done and a value. And you can use async iterables in for await x of y loops, where y is your async iterable. And so what's great about this is that we can use async iterables to stream data. And because they're like a native language construct, we don't need any libraries like pull streams. We don't need in the browser to have like a Node.js stream implementation. So that is awesome. And at the moment, most browsers or and other JavaScript runtimes already implement for await of loops, or already implement async iterators. So there's no need to transpile our code. So we're at a good time for introducing this. And like I said, we don't need to use Node.js streams or pull streams anymore because of it. If you do happen to be working with pull streams or node streams, then it's actually pretty easy to convert between pull streams. I wrote 2 modules, they're about 20 lines of code. It's super easy to convert between a pull stream to an async iterator and vice versa. So if you happen to be working with pull streams, then it's easy to, the upgrade path is pretty easy. And the best thing about this is that if you're working with Node.js streams, then there isn't really any need for an upgrade path because they are actually now async iterables, which is super rad. And I believe browser streams are also going to soon be async iterable as well. So hooray for that. And what does that mean for IPFS? Well, it means that there's none of this kind of multi-API for like add pull stream, add readable stream, and because of that, there's going to be a smaller bundle. There's going to be fewer dependencies because we don't need to include pull stream library. We don't need like associated Node.js stream libraries like pump to make sure we catch all of the errors and things. So that's going to contribute to having a smaller bundle for the browser, which is super rad. And because we've got a smaller surface area for our API, there are fewer tests to run. We don't have to test all of the different combinations of pull streams. There's only one entrance point, which is IPFS add, rather than IPFS add readable stream, add pull stream. So that's cool. And having smaller surface area means that it's easier to create a interface IPFS core compatible interface, because there are actually fewer things to implement. And on that point, like because there's fewer tests to run, the tests are going to take less time to run also. So that's cool. And then in IPFS, we use pull streams under the hood exclusively. So when we expose a readable stream API for some of our methods, we basically have a bunch of boilerplate code which converts between Node.js streams and pull streams, and obviously their associated library to do that. So there's less boilerplate in our code, so that's all win-win. In async iterables, it's way easier to handle errors. All you need to do is put a try catch around them. In Node.js streams, unless you're using an external library, it's kind of difficult to make sure you've caught all of the errors that could occur in a stream when you pipe them through. So actually having a kind of easy way to just try and catch errors is really useful and nice for developers. And it also means that by using async iterables and async await, we get better stack traces. And our stack traces aren't clipped to async boundaries anymore. So that's a better developer experience when debugging. And it just makes it easier to find errors, makes it easier to fix them. And yeah, better for developers, hooray. All right, okay, I've talked loads. What does it look like? Cool. So if we're going to create a IPFSX node right now, we need to require IPFSX, and we also need to require IPFS or IPFS API. And one of the other things that's in IPFSX is we can just await on the node to be ready. So at the moment with IPFS, we have to use or attach a listener for the ready event, and then we can use our node. And so for pretty much all people who are using promises or async await, they'll basically create a wrapper around this, and this is just done properly, done in the library. You don't have to do it anymore. There's less code for you to test, less boilerplate for you to write every time. So yeah, just makes it a little bit easier to use. So we just await IPFSX and our IPFS node is ready to use. Super rad. And so adding content. So this is the big entry point. All you do is node.add. Node.add, and that can be a string, it can be a buffer, it can be an iterable that yields buffers or strings or objects. And if it's objects, it means you're adding multiple files, and you can specify the paths and the content, just like you can with IPFS API, but it's a bit more permissive. And And so what node.add does is it returns an iterable. So we can use it in a for await, because previously node.add would call back or resolve with an array of the files that it had added. And so when we're adding stuff now, it's an iterable and we can iterate over the results. And each item in the result has a CID property instead of hash property because it's a CID that we're dealing with, and then we can use that. So that's kind of cool, but a lot of the time you want to just add one thing. Like in this case, we're adding one thing, and actually like this loop is going to run and it like go around once and then exit. So for that case, we have like our iterators that are returned from our ipfsx methods have special properties called first and last, and that allows you to await on them. And all that will do is that's kind of shorthand for this previous slide where we're getting just one item out and then breaking out of that loop. So when you know there's only going to be one thing returned, you can just call .first on the iterator and await it as shorthand. So that's kind of rad. Streaming add. So again, you remember I told you that Node.js streams are iterables. So you can add an iterable, and Node.js streams are async iterables. So here we can just add fs.createReadStream, and that will add the file to IPFS and get the first item out. If I wanted to add multiple items, again, we're adding an array is an iterable, if you remember I told you earlier. But in this iterable, we can define a bunch of objects that have a path and a content, and the content it could be a string, it can be a buffer, or it can be an iterable that yields a string or a buffer. So this is how you'd add multiple files. And then we can just loop over the results. And in this case, we're printing out the CID and the path of the added files. So hooray! And then, okay, so you might not get this, but so you can create your own iterator using generators. And generators are functions that when you call them return an iterator that you can iterate over their values. So if I wanted to create an iterator that would 10 times print out some or yield some random bytes, I'd do it like this. So I create a function, I have a for loop in here, and I yield random bytes. And again, I just do await node.add, and then my generator, I call it to get my iterator out, and I grab in the first one. Yeah, cool. So that's just a regular iterator. If you had like an async iterator, you create an async generator function. So you can see the difference being async and new promise here between these two. So we're basically doing the same thing, but what we're doing is we're saying this is an async generator, instead of yielding a value, we yield a promise which resolves to a value. And the value is just some random bytes. And we do exactly the same thing as we did before to add it to IPFS. Yeah, cool. And then so once you've added stuff, you want to get it back, right? And the similar sort of interface here, we've got node.cat to basically grab the contents of a file that you've added to IPFS. You give it a CID and some options, because, well, we'll talk about that later actually. So we give it a CID, and then we can loop over the chunks of the file that we want to cat out. And all we're doing is we've got some data, an empty buffer, and we add the next chunk to the buffer until we've got all of the data. So we're buffering up everything that comes out of that file, and then we could just do a call toString on that file, on that data, to get out our file data. Cool. And then so there is a whole bunch of other like methods to ipfsx, but they're not all finished yet. But there's a whole bunch of ideas and things, so you can check out all the API docs, and there's a bunch of like examples that are using it as well you can look at. If you want to hear more background about why all of these changes exist, then you can click on this link, and then there's for individual functions and other things, there is a rationale document which basically lists out all of the changes and the reasons behind those changes. So what I'd love to see from here is some like feedback. I'd love to know what you think. I'd also love it if you had any other ideas about how we could change it. What is your pain point when using IPFS that you would love to make it easier to use? And like if you feel as though any of the things here are wrong or need tweaking, then I would love to hear your ideas on that as well. So please open an issue. Before I go, the only other thing that I would like to highlight is, which landed just last night on the cat command, is abortable API methods. So this is one of the things that has been asked many times in IPFS. It's the problem that you ask for a CID or ask for the contents of the CID. It's not local, but it doesn't seem to be on the network, or you're not connected to a node that has it, or the DHT, you can't see it in the DHT either. And what that means is that your call to cat might never return. And so it has been asked for a whole bunch of times for like an abort, a way for the user to kind of cancel something, or for there to be a kind of timeout. And abortable API methods, there's one on cat now, which is basically, it uses the same kind of API for aborting HTTP requests as fetch uses. So you use an abort controller to create some sort of abort signal, which allows you to later cancel a request. And that just means that in your iterator, when you've got your for loop, if that iterator if that signal gets told to cancel, then it will throw. So it gives you a way of exiting the loop or exiting the method and continuing on with your processing. So that's super cool. But anyway, I've talked for ages and ages and ages. So please do go and try it out. It's at IPFS Alan Shaw ipfsx on GitHub, and please go and have a look and let me know what you think. Okay, bye.